Okay, we are going to find the limit as n goes to infinity of this long expression. Let's take a look. The limit as n goes to infinity of all that. Let me show you what not to do, because this is a super common mistake and a super common misconception for limit. So it looks that if we put infinity to the first term, we get 1 squared, which is 1 over infinity cube. Infinity to the third power is just infinity. 1 over infinity, which will get 0. I agree right here. If we don't have anything else, then this right here is 0, done. And if you plug in infinity to here, 2 squared is 4 over infinity cube. On the top is finite, the bottom is infinity, so we get 0 again, right? And again, if I don't have anything else, just this part, I agree, we get 0. And then we have to add them up, and then the next one is going to be the same thing, and then the next one is just 0, so on, so on, so on. And then right here we also have 0, and it looks like put infinity to the last one, we also end up with 0 here. So it looks like we just have this many zeros, and then when we add up zeros, of course we should just get 0, right? Well, be super careful. How many terms do we have? You see, we go from 1 all the way to n minus 1, so the next one right here in fact is n. We can get a common denominator real quick. Multiply the bottom and the top by n squared. So you can see that right here we have a total of n terms. N goes to infinity. This right here, you also have to kind of plug in into the infinity here. So how many this kind of zeros do we have? Well, right here, in fact, we have infinitely many 0. And in fact, this right here is not really exactly 0, because we're dealing with limits. So imagine if if n is a big number, this right here is just a tiny number, right? It's a tiny number, right? Okay. So technically you have infinitely many 0 plus. So when you have that, this becomes an indeterminate form, because you can look at this as infinity times 0. So we cannot draw any conclusion yet. Be careful with that. The answer is not equal to 0. Now I will show you guys how we are going to take care of this. In fact, we have 2 ways to do it. The first way is we first do the algebra and then take the limit as n goes to infinity. I will show you just that. The other way is calculus. We recognize this as a limit of a Riemann sum, and then we convert this into an integral, and then we compute the integral. But I think the intended solution is the algebra way, so I will do that for you guys. Here, this is the limit as n goes to infinity. First, we notice all the terms, they all have n to the third power on the bottom, so we can factor that out. Let's go ahead and put down 1 over n to the third power. And then what do we have left? The first term is 1, which is the same as 1 squared. Next, we have 2 squared, and then the next one is 3 squared, and then plus up to this right here is n minus 1 squared, and then the last one. Get the common denominator, right? We will have n squared, like this. This is such a long expression though. But in fact, when we have the sum of the first n squares, like 1 squared plus 2 squared up to n squared, this right here, we actually have a very nice formula. And I will write down the first 2 parts right here. The limit as n goes to infinity. And then this right here also states the same. But for all this right here, I'm not going to prove the formula in this video. Hopefully you have seen that in pre-calc. I'll just tell you what the formula is. The formula is we multiply this by n to the third power, by the way, n to the third power. Okay, all this, first we have n on the top times n plus 1, and then times 2n plus 1 all over 6. All right, we can verify this real quick. For example, if you want to do 1 squared plus 2 squared plus 3 squared, of course this is just 1 plus 4 plus 9, which is equal to 14. Yeah? And if we just plug in 3 because we ended at 3, if we plug in 3 into all the n's, we get 3 times 3 plus 1 times 2 times 3 plus 1 all over 6. Yeah, why 6? I'll just tell you right now, it works. There's a proof for it, of course, but let's check this out. On the top, we get 3 times 4 times 7 over 6. Well, you can reduce, well, you can just 12 times 7 is 84 over 6, and that gives you precisely 14. So it does check. So the formula does work. So now, let's go ahead and just reduce this and that. We can cancel one of the n's, and we will get n squared on the bottom. And we will have the limit as n goes to infinity. And we have n squared times 6 on the bottom, so let's put that down first. And then let's just multiply out the top. N times 2n, we get 2n squared. And then n times 1, we get n. But here we have 1 times 2n, that's 2n. Together, we get plus 3n. Lastly, 1 times 1, that's plus 1. And this limit is actually super nice because when we have n approaching infinity, in this situation, right, a rational function, we can just pick up the highest power of n on the top, which is this, and then also the highest power of n on the bottom, which is just that. If your teacher lets you to the quick way, then you do it like that. If not, you want to divide everybody by the highest power, which is n squared. But I think this is okay. Continue, you will end up with the limit as n goes to infinity. We are just looking at 2n squared over 6n squared. Right? These two terms don't matter, right? Because n is approaching infinity. They are the dominating terms on the top and also on the bottom. Here, we see that n squared cancel with n squared. So no more n. So the final answer is 2 over 6. And make sure you reduce that, of course. I've seen so many of my students, they don't like to reduce fractions in calculus. But anyway though, final answer, 1/3. So I'm not sure if you have seen the integral or not yet. If you have, I will tell you this right here. This is actually representing, I'll just put this on here. This limit actually represents the region, the area under y is equal to x squared. We go from 0 to 1. And we want to find out what the area is. And to do this, it's actually not bad. The area here is simply the so-called integral, and we go from 0 to 1. And then the function is x squared, and then dx. To work this out, you do the antiderivative first. That means you first add 1 to the power and you get 3, and you divide it by the new power, which is multiplied by 1/3. So you get 1/3. Let me just put this on here. You get 1/3 times x to the third power, and then you plug in 0 and 1. You are going to plug in 1 first. So you get 1/3 times 1 to the third power, and then plug in 0. So you have minus 1/3 times 0 to the third power. Of course, this part is just 0, so final answer is just 1/3. Yeah, this right here is the calculus part. I didn't go over any details right here because I have done a lot of videos on this. You can go check that out if you are doing this already. If not, then this is the only thing that you should know.